I got some live report. How you guys doing? I want to do a third math video. It follows up from what I was doing before, the golden ratio. This should be quick. Let's just show you guys something here. So if we start with the pentagram, it's terrible. Let me write it better than that. Okay, pentagram. Let's go like this. There we go. Okay, if this length right here is 1, and this length is phi right here, that means this length is phi. And that is true of a pentagram. So let me show you some interesting things about this. First of all, there's another there's actually 4 golden ratios within these three things. There's actually 4 different versions of phi. First of all, there's this length over this length, which is phi over 1, which is equal to phi. So that's a phi right there, this to that. And phi is 1.61803399. Okay, but there's also phi from this ratio to this. Let's see if that's true. If that's true, then that means that phi plus 1 over phi, because that's the ratio of this that's this ratio of this big one to this one right here, is equal to the ratio of this phi of this which is phi over 1. So yeah. So let's see if that comes out to be true. Because this phi over 1 is phi. Phi plus 1 over phi equals phi over 1. Let's see if that's true. You get phi squared equals phi plus 1, which is true. So that means this to this is phi over 1, which is phi, and this whole thing to this phi, the whole thing being phi plus 1 to phi is also phi, because phi squared equals phi squared plus 1, and it defines phi as 1.61803399. So that's two phis already. This one to this one, and this whole thing to this one. That's 2 different phis. But now we're going to do a couple more in this pentagram. We're going to do this whole line right here and see if we can find 2 more phis. So what we have is the first phi is this bigger length, which is phi plus 1, divided by this phi, which is the shorter length. This phi plus 1 over phi, this length divided by this length, if it should be, let's see if it's equal to this whole thing, which is 2 phi plus 1, that's the whole length, divided by 2 phi plus 1, divided by the large length, which is phi plus 1. So let's see if that works out to be true. Let's see if phi plus 1 over phi is equal to 2 phi plus 1 over phi plus 1. If that's true, then we have 4 phis within just this pentagram. Let's see if that's true. Let's do the math down here. I'm erasing part of the pentagram, not because I don't like pentagrams, but I do. Okay, so phi plus 1 divided by phi should equal 2 phi plus 1 over phi plus 1. Cross multiply, you get phi plus 1 squared equals 3 phi plus phi. Wow, that's complex. So phi plus 1 No, not 3 phi. Sorry about that, guys. I messed that up. 2 phi squared plus phi. Let's check it again. Phi plus 1 squared should equal 2 phi squared plus phi. Let's see if that's true. In fact, let's continue with that up here. So far I've got phi plus 1 squared equals 2 phi squared plus phi. We're checking to see if that's true. Let's see if it is. Okay. This is phi squared plus 2 phi plus 1 equals 2 phi squared plus phi. Minus phi squared on both sides. That gives you 2 phi plus 1 equals phi squared plus phi. Minus phi on each side gives you phi plus 1 equals phi squared. And that's correct because we know that phi squared equals phi plus 1, validating my assertion that within a pentagram, you have 4 different golden ratios or versions of phi. And that's really cool about the pentagram. There's a lot of magic in that, in other words. The pentagram is very magical. So remember that the values, phi is equal to 618033999. There's also phi plus, there's also phi minus 1, which is notable because it's 6.1803399, and there's phi plus 1, which is equal to 2.61803399, which are both important. But phi is 1.6180339. It goes on forever. It's not rational. It's a non-repeating decimal and not non-terminating decimal. Phi minus 1 is 0.6180339. Phi plus 1 is 2.6180339. So they're all important. These values are all important here. All right, love you guys. Peace, love, and rock and roll.